This is an example we worked on in class last week. This is for you Kairos guys. We're doing the same thing we did the week prior, except we're finding all zeros. Set it up. 5, 4. There's no cubic. 2, 1, and the constant. Set it up for synthetic division. 2 weeks ago, I gave you this value. And last week we learned about the rational root theorem, which took the factors of the constant over the factors of the leading coefficient. So this being 1, this being 6, you got 1, 2, 3, and 6. So the factors would be plus or minus 1, 2, 3, and 6. Not too many there, but we said that theorem has become obsolete. Now we take Frank, baby. He's here. Put in your calculator. Turn it on. Y equals, I got a x to the 5th minus 2x to the 4th plus 8x squared minus 13x plus 6. Graph. We see we have a x-intercept here, and we have a repeat here. They talk about it on the front side of this note sheet. It comes down to 1 and bounces up. Proof in the table. So -2 is an x-intercept and 1 is an x-intercept. Because it bounces off at 1, it means we have a duplicate or a repeat answer. So we'll see that in our division. So let's begin. -2, we should get a remainder of 0. 1, multiply outside the box. In the box we add. Multiply. -16, add in the box. -8, positive 16, there's a 3, there's our -6. So now we have a new polynomial. This would be x to the 4th minus 4x cubed plus 8x squared minus 8x plus 3. I don't know how to factor that. I don't expect you to. We had another 0. That was 1. Should have a remainder of 0. Bring down the leading coefficient. Multiply. Add in the box. Multiply. Add in the box. Multiply. Add in the box. Multiply. There we are with that remainder of 0. Now we're down. We went from a 5th to a 4th to a 3rd. So this is x cubed minus 3x squared plus 5x minus 3. Maybe grouping would work. If I took out a GCF, it looks like my coefficients would not work out. So grouping is not likely. And this is exactly why I'm doing this example. We can do it one more time with our repeat function of 1. Bring down the leading coefficient. Multiply. -2. Multiply. Add in the box. And there's our positive 3 for a remainder of 0. Now we have a x squared minus 2x plus 3. All three of these, I'm going to write a square for the duplicate here, and then a x plus 2. This is the complete factorization of this polynomial. Remember the directions said, find all the zeros. So you set this equal to 0, -2. We knew that from the calculator. Set that equal to 0, and there's 2 there. We have 3 answers thus far. Now we got to solve this. This is what's different this week as opposed to last. I'm going to use quadratic formula. X equals minus b plus or minus. I'll go use the calculator to get the discriminant over 2a. The discriminant, remember, I'm trying to get it so you can see it. All right, so second quit. The discriminant is b squared minus parentheses 4 times a is 1 times c is 3. Okay, A, B, C. Literally, you take the B, which is -2, and I square it. I know it's going to be a +4. This is the difference this week from last. -8 is our discriminant. If you got a discriminant that is a negative, that means you got two imaginary answers. So let's break this down. 2/2, plus or minus. I'll take out the -1. I'll take out the perfect square. Put that all over 2. So this becomes the common denominator to this and this. As you can see, take out your favorite chef's knife. 2/2 is 1, plus or minus. Square root of -1 is I. This is going to cancel with this. So it looks like I got a I radical 2. 1, 2, 3, 4, 5. We started with a degree 5. This is the fundamental theorem of algebra. If the degree is 5, I should get 5 answers. And clearly that is the case here. Thanks to the calculator. And hopefully this helps for the guys that missed. And I'll do another example and upload these to you guys. Talk to you soon.